Mountains. They're big, they're pointy, they're really, really bad for your calf muscles. But have you ever stopped mid-hike, gasping for air, questioning your life choices, and thought, wait, how did this thing even get here? Spoiler alert, it wasn't aliens, it wasn't a giant, and no, the Earth did not just sneeze and this popped out. The real answer is somehow even wilder. It involves molten rock, tectonic plates the size of continents, and a process so slow that watching it happen would make watching paint dry look like a Fast and Furious movie. So grab your metaphorical hiking boots, because today we're digging, literally, into the geology of how mountains rise from flat ground to Instagram famous status. Let's get into it. To understand mountains, you first need to understand that the ground beneath your feet is lying to you. It feels solid and permanent. It is neither. The Earth's outer shell, called the crust, is broken into giant puzzle pieces called tectonic plates. There are about 15 major ones, and they're floating on a hot, slow-moving layer of semi-molten rock called the mantle. And when I say floating, I mean it in the loosest, most geologically depressing sense. These plates move at about the speed your fingernails grow, which means in the time it takes California to inch a few centimeters closer to Japan, you'll have already given yourself 3 unnecessary manicures. But here's the thing, slow doesn't mean weak. Give these plates a few million years and they can crumple continents like a piece of paper, which, conveniently, brings us to mountain type number 1. Picture 2 tectonic plates cruising toward each other at the blistering pace of a few centimeters a year. Eventually, they collide. But rock, even really, really thick rock, doesn't just stop and say, my bad. It has to go somewhere, so it does the only reasonable thing. It folds upward, again and again and again, for millions of years, like the world's slowest game of accordion. This is called a fold mountain, and it's how you get some of the most famous mountain ranges on the planet. The Himalayas, formed by India, literally ramming into Asia, and honestly, it's still going. India is still pushing north today, which means Mount Everest technically gets a tiny bit taller every year. Overachiever. The Alps, Africa slowly bumping into Europe. The Andes, the longest mountain range in the world, formed by the Nazca Plate sliding under South America. Fun fact, because the Himalayas formed from an ancient seabed getting pushed skyward, climbers have actually found fossilized sea creatures near the summit of Everest, which means somewhere on top of the tallest mountain on Earth, there's a fossil of a creature that's more confused about being there than you are after skipping leg day and attempting the hike anyway. Not every mountain forms from a slow-motion head-on collision. Sometimes, instead of plates crashing together, they pull apart or scrape past each other, and that creates cracks in the crust called faults. When enough pressure builds up along one of these faults, huge blocks of rock can get shoved upward, while neighboring blocks sink down. It's less gentle folding and more geological seesaw with a bad attitude. These are called fault block mountains, and they tend to look dramatic, steep, jagged, angular, because instead of gradually crumpling, they basically just popped up. The Sierra Nevada in California and the Grand Tetons in Wyoming are classic examples. The Tetons in particular are famous for looking like they were just yanked straight out of the ground with zero warm-up. Geologically speaking, they kind of were. No foothills, no gentle slope, just bam, mountain. Very rude, very photogenic. Now, let's talk about the mountains that don't have the patience for slow folding or seesawing, the ones that just erupt into existence. Volcanic mountains form when molten rock, called magma, forces its way up through weak spots in the crust. When it reaches the surface, it becomes lava, and layer by layer, eruption by eruption, it builds a mountain from the outside in. Mount Fuji, Mount St. Helens, and basically the entire chain of Hawaiian islands were built this way. In fact, the Hawaiian Islands are a great example of a hotspot, a stationary plume of magma deep in the mantle that just keeps punching new holes through the crust as the Pacific Plate slowly drifts overhead. Think of it like a geological hole puncher, except instead of confetti, it makes entire islands. Slightly more impressive than your average office supply. And here's a fun bit of trivia. If you measure from its base on the ocean floor to its peak, Mauna Kea in Hawaii is actually taller than Mount Everest. Everest just gets more credit because it's the one showing off above sea level. Classic case of all the underwater effort going unnoticed. Sometimes magma tries to push up to the surface and just doesn't quite make it. Instead of erupting, it pools underneath the crust and pushes the rock layers above it upward into a dome shape, kind of like, and I promise this is the most scientifically respectful comparison I can make, a pimple. A geological, multi-million year, extremely large pimple. These are called dome mountains, and the Black Hills of South Dakota, yes, the ones with Mount Rushmore carved into them, are a great real-world example. So next time you see a picture of four presidents' faces on a mountain, just remember, technically, you're looking at the Earth's oldest unpopped blemish. Last category, plateau mountains. These aren't built up by folding or magma. They're carved out of large, flat, elevated regions of crust called plateaus. Rivers, wind, rain, and ice spent millions of years slowly eroding the softer rock away, leaving behind harder, more resistant rock standing tall as mountains and canyons. It's basically nature sculpting with an eraser instead of a chisel, subtracting rather than adding, which is honestly kind of soothing to think about in a world where most self-improvement content tells you to build and add more to your life. Sometimes greatness is just about removing the stuff that doesn't belong. Deep, right? Anyway, back to rocks. So to recap, mountains form in five main ways. Fold mountains, plates collide, crust crumples upward, Himalayas, Alps. Fault block mountains, crust cracks and blocks shift up and down, Sierra Nevada, Tetons. Volcanic mountains, magma erupts and builds up layer by layer, Fuji, Hawaii. Dome mountains, magma pushes crust up without erupting, Black Hills. Plateau mountains, erosion carves mountains out of raised flatlands, Catskills, Colorado Plateau. And here's the wild part. Mountains aren't a one-and-done event. They're still forming right now, under your feet, at a pace so slow you'll never notice, unless you're a fossil, in which case, congratulations on your front row seat to geologic history. Every mountain range on Earth is really just a very, very long-term progress report on a planet that never stops moving, cracking, folding, and occasionally blowing its top. Kind of relatable, honestly. So next time you're standing at the base of a mountain, sore knees and all, you can appreciate that you're not just looking at a big rock. You're looking at millions of years of tectonic drama, volcanic tantrums, and slow, patient erosion, all working together to build something genuinely massive out of, honestly, almost nothing. If you learned something today, drop a like and subscribe for more videos where we break down how our planet works, one surprisingly dramatic geological event at a time. Thanks for watching, like and subscribe, and until next time, watch your step. The ground's doing more than you think.